right, it looks like we have everyone. So we're going to take questions from the audience. What we're going to do is I'm going to give priority to people who go to a mic and ask a question. If you're stuck in the center of a thing, we'll try and hand a mic to you and make sure we get folks. But I'm going to start with the people who've lined up. Everybody's got their water. Everybody's ready to go. None of them fled.
He's behind the microphone.
So let's begin. Sir, is your mic on? Please go ahead and ask the question of the panel.
I'm George Sutton, and I really want to thank Dean. Hello, Dean. Dean, I'm over here. I want to thank you for opening my eyes. There's science that studies things. There are engineers that build things. But there are inventors who invent new things based upon science and engineering. And in fact, most of my career has been I've always told people I'm an engineer, but in fact that's wrong. Most of my good stuff has been inventions. And I want to thank you very much.
Very good.
Thank you.
I'll ping pong back and forth. Sir, on this side.
I'm Andy Jackson from the University of Pennsylvania, 35 years with ExxonMobil before that. I'd like to make an observation, and then that would lead to a question. The observation is that when we see the videos are the sort of things that high school students can identify with. So we had virtual reality, they have solar energy, they have access to clean water. But none of them remember the term mutually assured destruction, so they don't really identify with nuclear power or terror. None of them get sick, so they could care less about the medicine ones. And they don't know what the nitrogen cycle is. So when we're trying to get to high school, I think we shouldn't be focusing so much on the kids as the teachers, and make sure that all the teachers in the high school understand these and understand the relevance of them. And not just the science teachers, the social teachers, the geography teachers, everybody. These are the global issues, because they're the ones that are influencing the students into what careers they're going to go into. And unfortunately, most of our high schools, at least in the United States, don't have engineering programs in the high school. They come out of there, they do math, physics, science, they don't know how to put it all together. So that's one of the things that we need to address. So the challenge I feel is we should get to the high school teachers with these. So maybe the panel can comment on that.
Does anyone have any views on it?
Well, we certainly agree that we need to get to the high school students, and the best way to get to the high school students is to train the teachers, no question about that. And maybe we need to address them differently rather than man build bridge. Here is somebody that is resolving a problem, because it is a problem. The bridge is, to cross from point A to point B is a problem, and somebody thought about it and did this and this and that. So it's in the matter of presenting the data, presenting the information, presenting your issue. So absolutely, we agree that the teachers should be continually trained to make absolutely certain that the kids would get that information so that they can get enthusiastic about it.
Very good. Sir?
Yes, my name is Mike Silovich. I'm a professor at Northeastern University. And, you know, what has really inspired me by the panel is the question, how do we think systemically? The definition of the grand challenges is one element. You've thought big picture. You've defined 14, really key areas where we can make a difference as engineers. So the next question is, how do we implement, or as Dean Kamen says, how do we make it louder so that it really permeates our society? And how do we leverage existing mechanisms to make that loudness occur? And I'll give you one example. One example is the capstone courses that we impose, if you will, on all the engineering juniors and seniors in the colleges, at least of the United States. And the question is, can we orient the capstones and make them systemic to address the grand challenges? And then as a capstone on the capstone, have the equivalent of something like FIRST, call it We Can or something like that, to effectively highlight the the focus of these capstone courses on the grand challenges at a national and an international scale. So the question to the panel is, how do we think systemically?
A couple questions there. Is that the place to make this a systematic thing? Sir, Wes, you had some thoughts about revising credits. Is that a good approach?
Yes. May I respond first?
Please go ahead.
Right. Sir, thank you for the question. A very important question. I offer the following, that perhaps we should not wait until the capstone design experience. I think we've demonstrated up in Massachusetts that you can teach design to first-year engineering students. And I don't think there's anything unique about Massachusetts in that regard. What's a robot? They come in various shapes and forms. For example, we had a first-year student to take advantage of the black soldier fly, which does not transmit diseases, but devours protein, basically, and convert it to fertilizer. Okay? You don't have to write a computer code. It's already there. And we took that to Ghana. It actually worked. First-year student. So what we want to do is to make sure we bring the idea, the big four, including sustainability, into the picture early into the careers of our engineering students, and encourage them to actually develop a product, a device that serves humanity. And I mentioned earlier this idea of credits. An example, ABET comes to evaluate a program in civil and environmental engineering. If that program has elements like your recommendation of a capstone design that involves our grand challenges, then that should be a credit. That should be a credit. And that's what I meant by credits throughout the system. Grade school, high school, our engineering schools, and even our industry should receive credits, tax credits, for example, if they are engaged appropriately within their mission, supporting and expanding, bringing a loud bang, Dean, to the grand challenges.
Very good. Well-constrained questions from folks from the audience. Go ahead, ma'am.
Yeah. So there was a point brought up earlier. I should say my name is Janet Herring. I'm from the ERWAG, ETH Zurich, and EPFL in Switzerland. There was a question earlier about also moving beyond education. Of course, education is very important to many of us in the audience, but not the only thing. And I noticed that there's a lot of overlap between the grand challenges and the Sustainable Development Goals that were adopted by the nations of the entire world at the United Nations General Assembly just in the last week. And I think that would be an opportunity then to broaden beyond education, look for leverage, as one of the previous questioners pointed out, and say, well, how is it that, where is the overlap between the grand challenges and the Sustainable Development Goals? How could engineers get involved in the implementation of the Sustainable Development Goals? The Millennium Development Goals were very effective because they had a series of indicators, and so do the SDGs. So that's the challenge I would like to put to the panel. Is that something you would see as a possibility? And if so, how would the Academy get involved?
Do you see the Academy working with the UN this way? Does this seem reasonable? Yes, sir, go ahead.
Yeah, very important point. I was actually responsible for drafting the science and technology components of the MDGs. And the new Sustainable Development Goals basically is a slight expansion of the MDGs. And I cannot see those SDGs being implemented without a strong engineering component, because all of them are very much linked to solving particular problems. And this has been an issue mostly from the diplomatic side, in that the diplomats who formulated the SDGs took way too long to reach out to scientists and engineers. But it opens a window by which the academy can engage. And I think the best way for the academy to do that is through other academies in other countries rather than direct to the United Nations. I've worked in the UN before. I would not recommend this academy trying to engage directly with the UN agencies.
Okay, ma'am.
Okay, I'm Fran Ligler. I'm currently at 2 universities in North Carolina, and I'm actually teaching a course to college freshmen on the NAE Grand Challenges. And we've been developing this course for a couple years and are going to expand it to about 2,800 people within the next 2 years, opening it beyond just engineering. It really does a wonderful focused job on teaching young students that they can develop the skills to address sustainability on the planet, and that they have to work with other people, including those pesky scientists. But what I wanted to ask you, then, since you've been involved in this from the start, is what's the 15th Grand Challenge?
All the above.
Go ahead.
I think the 15th Grand Challenge is, I keep coming back to the same one. In fact, in 1940, President Roosevelt said, we cannot create the future for our kids. We have to create our kids for the future. And the future is moving much faster than it's ever moved before. Typically, a generation or two of engineering success leaves behind the unintended consequences. We made plastics, they were great. Now there's too much, and we made cars. One car was a work of art. 100 million cars is a traffic jam. We typically take a generation or two to solve a problem, and then it leaves behind others. At the rate at which technology is moving, kids are going to catch up to their own problems so quickly that they won't have a generation to plan, sit around, come up with grand challenges. I would suspect in 50 years, when we look back at these 14, somebody commented yesterday, the last time they did this, it was all about building stuff, the 20th century. It was plumbing, it was airplanes, it was cars. Now, already we've seen it's interconnected system-level global issues. 50 years from today, there will be a host of problems that we're not even thinking about. I think the 15th Grand Challenge has to be to create an environment in which people are way more capable of communicating, cooperating, and a much larger percentage of the people on this planet, whether they're practicing engineers or not, are at least competent to separate fact from nonsense, even just so that when their governments deploy resources and assets, they do it in an intelligent way. And that's going to be the real challenge, keeping one step ahead of whatever is the impending catastrophe, because they're going to come faster and faster.
Sir.
Could I be controversial and suggest that a challenge should be to provide for the women of the world the knowledge, education, and means to control the number of children that they have?
I was afraid
In some countries, the birth rate is actually a major problem. It's not sustainable. Look at countries like Singapore and Japan, Taiwan, a lot of these Asian countries.
Yeah, I realize that, but there's an awful lot of the world where that's not the case.
I was afraid to ask that question. Thank you for asking. Go ahead, sir.
I'd like to bring it back to education. Don Chaffin, University of Michigan. It strikes me that we've recognized here several times the breadth, the complexity that's involved in these grand challenges. In the past, we've also talked about the need for engineers, particularly that are launching a broad career, have high goals for themselves, hopefully all engineers do, that they need 5 years of education. They need a master's degree. And Dean, I point at you, for instance. You're the H person, as I see it, and yesterday we heard we need I people, even better than H. I'd like to have somebody, and hopefully several people talk about that need to raise that bar up again. We have not talked about it in the academy for years, as far as I remember, that the entry level of education here is not 4 years in an engineering school. It's 5, it's 6 years, and so forth. I don't want a surgeon with a 4-year education to operate on me. I don't want a lawyer to take my case and so forth with 4 years of education. Why do we expect 4 years of education to be sufficient to deal with these kind of matters? Thank you.
Anyone disagree? Won't they go to Wall Street if you make them go 5 years of engineering?
Strikes me the question is much too narrow. We want to educate people to participate in these grand challenges in many different ways, including equivalent of, I guess, a 2-year engineering education as a support position. I mean, it seems to me that's a very elitist way of posing the problem.
Now we have a debate.
In many developed countries, I think we are now facing a situation, including places like Singapore, where the young people don't want to go into engineering anymore. Many of them go into engineering to get a bachelor degree and then go into finance and banking.
Right.
So this is really, I mean, as a profession, I think we need to reflect upon ourselves how to basically inspire the young people to take on engineering. So one way we do this is we want to make sure science, maths classes that people taking in junior high school and high schools are not just textbooks, that they can see that they are relevant to real problems. And I want to add on to a previous question, which is we not only want to see changes in education, but more importantly, many people here are either running labs in universities or in companies. If we take on students at a young age, we have students as young as 15, 16-year-old, come and do research project with us. And you'll be amazed at how fast they can pick up on research, and they become hooked on it and come back again and again, and that's the type of people we want. We don't want people to drop out and we end up having a leaky pipeline. We don't want people to just see engineers as elitists. We need more people to get into engineering. At the very minimum, you created a very large pool of people who appreciate what we do. And that, I think, really is really the key message here.
Thank you.
Very good. Sir?
Norm Scott from Cornell University. I guess after Dean Kamen said something about the 15th, I would be questioning the 16th. One area that I don't see explicitly there is food, a pretty important area. I wonder how the group addressed that issue of food and decided not to address it more directly.
I think we have a couple responses. We'll start with Farouk.
In some ways, food was discussed in the water question, because without water you cannot really produce food for animals or for vegetation or animal husbandry. So it was implied in, as far as I'm concerned, in the water issue.
It was also in the discussion on the managing the nitrogen cycle.
But you're referring to food security, right? Maybe? Yeah. Food in its own context. Okay. In some ways, it's also embedded in the engineering better medicine, because a lot of things that we look at in terms of detecting certain elements, diagnostic and detection in food testing, they come together. Okay, and also we are looking at a lot of technologies that will let us know what is the impact of taking certain food in terms of on the health and development of illnesses. Okay? But you're right, I think that's a very important area.
Very good. Ma'am, go ahead.
I'm Christina Katsaros. Last job was with NOAA at the research lab in Miami on hurricanes and climate and so forth. But my issue has been bubbling up all morning, and so it was already mentioned, the problem with population growth. And I've read some report I reviewed that we were going to top off at 9 billion, and I hardly believe that. We have been increasing. Education of women is very important, and that was mentioned. So I am not original anymore, but it had not been mentioned all morning. And to me, the question to the panel is, if we keep on growing, and certain countries, and Africa especially, The people are so young, they're not going to know other things, history even. But if we keep on growing like that, the curve goes up. And even if it levels up, it's still very high. Now, the technological advances that will help our sustainability in the food supply is not crossing that curve. Do we have technologies that can minimize, use less resources, that we can actually bring a higher standard of living to all of the future large numbers of people? That's a question for anybody on the panel.
Sir.
I suppose if I were to nominate a 15th, although I also plead that it was 8 years ago and I don't remember why food didn't emerge as a challenge of its own. It probably had a variety of accidents about our feeling it was included somewhere else. But those are the kinds of questions, at least, I'm not going to be able to answer almost across the board. But on population, there really is a dichotomy right now between parts of the world where the population has, demographic transition has not yet happened. There are parts of Africa, India, Middle East, and much of the world where it has, and where there's a whole set of issues around constructive aging, fulfilling the later years, medicine in later stages, and keeping it under control. There's the demography of having a population that is much more heavily tilted toward older people than it ever has been, which is what controlling your birth rate and bringing it to replacement level or below entails, and also the prospects of shrinking population. Jackie mentions that Singapore is going to get a smaller population over years. Japan, Italy, other countries heading in the same direction, Russia. Well, do we just regard that as a terrible threat, or do we find ways to make that an advantage? So I think there's a whole cluster around the second half of life, or the last third of life, or something which is going to loom very large, and I would bet will be on the list in 30 years. It could have been on ours.
We're still larger population than we had when most of us were young, double since we were young. So if we went back to half, would be just fine, in my opinion.
It's interesting because it raises the issue about, if you see most of the country that's having too small a population, it's the quality of life reaches a certain point. The population basically becomes very well educated, and women wants to work, and therefore they have to juggle many different things. And places where the population is a bit out of control, they are facing a lot of issues with low quality of life, and that population somehow also get controlled because of some of those issues. This type of things, I mean, it is really probably a social grand challenge, but maybe the engineer's role in some of these things probably has to do more with working with a lot of other issues, including public policy issues. Yeah.
Thank you. I'm going to try and keep it to just one question from folks. Yes, sir, I believe your name.
Alfred Grill from IBM. I'm looking here at the board and I see 14 what I would call global challenges for humanity. At the same time, and I didn't hear so far how are we going to address these challenges? It seems to me that the entire discussion focused on the grand challenge of education. And I think the problem with this grand challenge for engineering is not because of lack of engineers. I think we have to educate future engineers with better qualities, but unless we instill in them the eureka moment, I don't see a path how to address these challenges. And one point which is not addressed at all is funding. All these challenges will need solid funding. How do we get the funding for them? Two of the challenges are at least 40 years old. Solar energy to make it economical, fusion energy. So if we're continuing at that rate, 40 years not finding a good solution, then we have a problem. And I think one of the major points is how to get good funding, and maybe we should prioritize these challenges. Which is more important to get good funding to invest in research? I say still needs research first and then engineering.
Is prioritizing them a fruitful thing, or is that a bad idea? Is that,
For the audience, we had a predecessor document when we started working, this I do remember, which was the Major Achievements in Engineering of the 20th Century, which was a coffee table book that had been completed about a year before. And it did order the inventions of the 20th century, and I think electricity is first and automobiles are second, if I remember. Is that correct? And we were told it was our job to order our list. And we rebelled. And we held the staff of the Academy off. So, because we felt these were incommensurable, there was no measure we could think of, like impact, that would leave electricity at the top, that we could possibly display. That's just for the record. I'm glad we did, but maybe others would regret that or want to do it now.
There's a second question he's kind of asking in there about, we're in a world right now that supposedly is awash in capital that doesn't have an outlet. If these are such great ideas, some of them have been taken up, but like when...
And also in China, when there's teams, about, I don't know the number, 50 teams from different countries, had worked up projects inspired by this list, almost every one of them on the list inspired some group of people to a solution. Maybe everyone, I don't know, but I think close to everyone.
Sir, please go ahead.
A number of these Misha Schwartz, Columbia University. A number of these grand challenges have to do with the negative consequences of humankind on the earth on which we live over history. Yet in this country, the United States, a substantial number of people don't believe in global warming. A substantial number of congressmen don't believe in global warming. Many of the candidates for president don't believe in global warming. So how do we overcome these adverse comments by people? How do we advertise it broadly? The question of funding was raised. It has to go through Congress. If Congress doesn't believe in some of these things, how can we do this? So how do we get these points past, these adverse consequences? How do we educate people who don't believe any of this?
Does anyone have any thoughts about beating them?
Well, I personally think that's a really important question. I was going to allude to it at several times this morning. I did bring up climate change specifically to get that out of the audience. So thank you. And I think it's the issue is, are we losing, particularly in the United States, the conviction that the scientific method is a privileged way of knowing? There are lots of other ways of understanding the universe, but it has a special way it has special features that give it, should provide it dominance. We need to join that issue. We need not to hide from it. And lots of people resist it. They prefer to have a religious way of knowing as a dominant way of knowing. They don't like it. So we need to join that issue, and I think the academies do that a lot, but they can't do it too much.
It's interesting that if you look at other national academy, for example, the one Germany, Leopoldina, they have a very active role once they were designated as the national academy to work with the government to come out with policy papers. I mean, there's really a lot of role that the academy can play, besides being an honorary organization, to put together certain things to advise the government and make sure the voice of the profession gets heard.
The challenges are a call for another heroic age of engineering, in a sense, but it's, do we have to do more than say, here are the challenges, here's a way of thinking about challenges as well? Is that part of what you wanted to get out, or you're just stuck making a list and there you go?
Yeah, when we started, we were thinking of these are the challenges to the human mind, not the programs that the NAE or the American Congress would pursue. These were just challenges in the field, in the whole vision of engineering. What is it that we should be thinking about to resolve issues that we resolve? People of the earth, think about these. That's all.
Yes, sir.
I think somebody a few minutes ago was talking about engineering as if, is 4 years enough or is 5 years enough? And again, like engineers, everything we like is color-coded and numbered. It's a process at a beginning and an end. Well, life isn't that way. And you're pointing out another aspect of life not being that way. Engineering doesn't start at engineering school, and it certainly doesn't end when you graduate. Again, more than any other field of human endeavor, it's changing all the time. You read the classics. If you're an English major, I'm pretty sure Shakespeare is going to sound the same in 2050 as it sounded in 1950.
They do make a living reinterpreting it, though.
But the fact is, You leave engineering school, and 2 or 3 years from then, at the rate we're going now, virtually everything you learned other than the canonical basics are irrelevant. So, engineering shouldn't start by the time you're 19 or 20. It's a little late. I keep coming back to these same analogies, but the NCAA and the Olympic people don't start looking for kids to compete when they're 18. They're pretty much retired by then. And the academies around the world need, in every field of endeavor that they're in, to get to younger and younger people to affect a whole society. And now you're saying, somebody is asking how you fund it, and you're saying as a professor, we have people that want to be president that don't understand this stuff. Well, they not only didn't start engineering at 19 when it's too late, and then they never started at all because they're part of a culture in which they never had to deal with reality. In fact, they're in this democracy of ours in which we all think it's very great. But frankly, I think half the people in this place probably like the world of engineering because they know some bum doesn't have the same right to an opinion on the second law of thermodynamics as Enrico Fermi. And the fact is, a democracy is a very inefficient system. It's the best one we got, but it'll only work if more than 50% of the people get it right. It used to work very well because most of the critical issues weren't these 14 grand challenges. They were mostly self-inflicted wounds. Do we want slavery or not? Do we want to? But now, as the entire global population has to start dealing with real technical problems, if our democracy doesn't start producing kids that have at least enough passion about learning science and technology and math and engineering and logic, that by the time they get to be adults, whether they're engineers or not, if they're not competent to deal with the world they live in, we're going to get what we deserve. And somebody asked at the beginning, what should we be doing as an academy? We should be making sure that when we go out to each of our own individual disciplines, any one of those 14, somebody wanted to prioritize them. Here's the good news, prioritize them any way you want. The self-selection by which somebody loves one of those problems versus another because of their background or their history, great, they all need to be solved. We don't have to do that. But if this organization continues to come together and exchange ideas just among ourselves on what you do in this problem and what I do on that, and then we all go off, that's not what an academy ought to be doing. We each work on our own fields of expertise to raise the bar there, but when we get together collectively, we should be looking outward at the kids and, to your point, at the politicians. It is wholly ridiculous that we let these people get away with the nonsensical things that they say, but there's no countervailing voice because the technical community thinks that's not my field. Well, being a citizen is our field, and there's no other place that we can bring some sanity to the system unless the technical community, as one big voice, as an academy, starts talking to kids and to politicians about the difference between facts and nonsense and what's important and what's irrelevant, and we need to do that.
As someone As someone who covers Congress, I can tell you, actually, when you speak, you are heard, if not by the congressmen themselves, by their staffs. They're well aware of this stuff. And if you've listened to the tone in the last debate, it was, we can't afford to fix this. It wasn't so much this isn't happening, although, of course, there's outliers. So I would not be so pessimistic at this point. I'm sorry, Callistus. Okay. Let's see, I've lost track of which side of the room I'm on. This, sir, yes.
Yeah, John Kasakian, MIT. I think that the Academy actually has a dimension that could be used very effectively to leverage attention to these grand challenges, and that's the National Research Council. Many of us, I'm sure almost everybody here, has served on one or more NRC committees. Now, these committees, and there are hundreds of these committees in operation at any one time, are all addressing aspects of these 14 grand challenges. And the committees are composed of experts in these areas. And I haven't thought this through very far because it only came to me while I was sitting here listening to the panel. But it seems to me that there must be a mechanism for taking these studies, or a piece of these studies, or at least the fact that these studies are addressing a specific issue within these 14 challenges, and bringing them to high schools, or maybe even grade schools, in some way that makes them aware that, in fact, there's this important question that a group of experts are dealing with right now. What do you think about it? And these experts can, in fact, be, if they have the time, be emissaries to some of these schools to help them think about these issues, even while the committee is functioning to try to address the question that's been asked by Congress or whatever. And this is another way of getting the students engaged with the fact that the political process has a strong influence on what happens with science and engineering. And science and engineering can have an effect on the political process through the action of these committees. As I say, I haven't thought through how this might be implemented, but it seems to me that it's a very valuable resource that we shouldn't overlook.
This might be a question I did Dan Mode up with, how does the Academy get that done? We've talked a lot about making things work in the high schools. I mean, that a formal package, of this thing, that's something that seems reasonable, or is there a problem there? No opposed.
I think we took, Professor Harris and I took this to high school, and we were just very surprised by the interest, enthusiasm. Professor Harris came and talked to the entire school. And I think that that's probably the best place to start as far as I'm concerned. I do remember that the original statement of task said, grand challenges for engineering for the next 100 years and beyond. That's what the statement said. Yeah. And that signaled to me that this is a long-term issue. And because it's a long-term issue, the best place might be to start with the people who are likely to be here in the long term.
Sir.
I'm Ron Latanison. I'm a senior fellow at Exponent. I'm also editor of The Bridge, which I hope everyone in this room reads every quarter, cover to cover, but I'm not sure that's true.
The editor.
I want to turn, Lord Burroughs, to a comment you made about social science and the involvement of social scientists in what we do as engineers. I think, and I've heard in the comments, recent comments, many manifestations of the fact that I think the public is apprehensive about technology and engineers and in their involvement in technology. I think nowhere is this more true than in, for example, the interest of young people in studying science and engineering. But in terms of the implementation of technology, it is certainly true in the way we handle the issue of the management of nuclear waste in the United States. That translates into Yucca Mountain. And there is clearly a political dimension to Yucca Mountain, but there's also a social science dimension. Now, I'm interested in how you have handled that issue in the UK, because I believe that Sellafield is a more tractable potential geologic repository. I know it's more true in Sweden, and I believe also in France. And I believe social scientists have played an important role. What is your experience, sir?
It's an extremely difficult issue. I mean, in the Lords and the Commons, we've conducted endless inquiries. The problem we've been having in the UK is getting geographical locations to accept having an underground store. I mean, the basic methodology is to, first of all, store the waste in a containable way. I mean, we have some water tanks in Sellafield that you just don't want to think about, that are corroding away and filled with highly radioactive waste. That has to be taken out and put into stainless steel containers, and eventually those containers stored way under the ground. We've had some fairly vicious campaigning against this, even in what we have regarded as safe sites. So I don't think we're a particularly good example of how to proceed, because it's the planning difficulties have stalled our process at the moment. The amount of money we are predicting to have to spend on nuclear waste is absolutely vast, and this is because of the legacy waste, not the new waste that would be produced by new power stations, but the waste we have already. The cost of storing that waste is predicted to be over 100 billion pounds. And the timetable is now into the beyond 2100. Canada is the place that I think has done better. They seem to be ahead of things. So I don't know whether that answers your question. I don't think it does.
Is that a 17th challenge we're up to? Is that... Sir, go ahead, please.
Thank you. I'm Nelson Martins, joining this year, enjoying every minute of it. And my comments is regarding some revising the grand challenges text statements. One, illustrious panelist has already said, which is removing urban and keep it infrastructure. So this becomes a sub-item, the urban. The other is, I didn't say where I come from. I'm an Electrical Energy Research Center in sunny Rio. And prevent nuclear terror. Why not prevent nuclear disasters? Terror included. Less hysterical. That's good. And the other is provide energy from fusion. Why not provide energy from all potential sources? Fusion included. Thank you.
So I didn't know this was going to be defend your choices.
I tried at the beginning to derail that. I mean, I think it's completely unproductive.
Let's go ahead on that.
Okay, I'm David Nethercott from Imperial College in London, and like the last speaker, I'm a visitor here, so I'm really accepting things pretty much at face value. And to me, the grand challenges are not an agenda. They're actually a vehicle for publicising and gaining support for the value of engineering. And in that sense, the 14 items listed there are less important than that there is a list, and it's a believable list. When I was much younger, I learned two important lessons, not in an engineering school, but actually in life. One was that you can't sell cleverness, you can only sell benefits. And the second one was to understand what's success for the person on the other side of the table. And I'd like to associate that with two comments that came from Alec and from Dean about two potential parts of the audience, politicians and kids. And I have a 10-year-old grandson, and I have to tell Dean that two of his passions in life are Lego and Will.i.am. So that's exactly the way to get to people of that sort. So my question really is, to what extent, given that the Academy would wish to use its influence to take this agenda forward, this vision, as it were, forward, what is it doing about identifying the target audiences and the benefits associated with those different components of the audience in order to gain greater acceptance and greater traction?
Is that the question today? Yes, sir. Go ahead.
First of all, thank you. I violently agree with you that these 14 are examples of big problems and examples of what a creative mind ought to believe are things we can solve. And by the way, the enlightened self-interest of kids is not only that they can fix the world, and this generation and across the world, as I've seen it, is more interested in that, probably because of the technology that's connected them all, than ever. And also, I think it can show them that their personal self-interest, these are career opportunities that can make them very successful. So again, thank you for, I think, pointing out this isn't an agenda, and again, to somebody else's point, not only do we not need to prioritize them, I'd throw them up there and say, whichever one of them gets you excited is your first priority, and I'm sure the laws of large numbers will leave us with lots of people working on all of them if we can get lots of people comfortable to play with technology. So thanks for that. In terms of how do we get to an audience, particularly of kids, I've been saying for a long time, not only do we start too late by letting kids think about engineering after they graduate high school, which is insane. Let's think about becoming an athlete after you get out of high school. Have you ever seen basketball? I don't know. So I think making it relevant even to young kids by example, F equals MA. We're all told the greatest mathematician, scientist of all time, Isaac, F equals MA. To a non-technical person, A equals B times C. Well, the only simpler mathematical statement than F equals MA is A equals B, and it reduces to something trivial. My point is kids, we teach them esoteric stuff that they can't comprehend. They don't appreciate the elegance or the beauty of it. They go year after year with counting and arithmetic and trigonometry, things that have no relevance. Instead of like everything else they do in life, they see people playing baseball, the thing's whizzing at 100 miles an hour. We stand it still, call it T-ball, and they feel good at 4 years old when they become part of baseball or cricket or whatever you want. But the fact is, we have to make it relevant, and these things are very relevant. Kids all over the world are scared to death about environmental issues or food or water. We can make it. In the world of science, you tell kids there's 300 billion stars in the universe. They'll believe you. You put up a sign that says wet paint. They have to touch it to be sure. We have to make science, technology, engineering, and math relevant and comprehensible. They have to see a need and an excitement and a path to do something. And where you started, if these 14 things, any one of them, lights somebody up about, I can do something about that, then that's your audience. And we have to figure out how to nurture them, whether it's a kid or whether it's a politician. People need to get passionate about things that matter. And the technical community has pretty much made it impossible for them to do that with the tools we have. These things can be very inviting and bring them in.
Yes, sir. Go ahead.
I really think the one missing component right here is the fact that probably we need a children's book for each one of these challenges. Some book that is just designed for children on these challenges, outside of the classroom.
Sure. Sounds like a good idea. Yes, ma'am. Please go ahead.
Yeah. Jenny Huang, H Technologies Group. Here we have 14 grant challenges for engineering, which are grand and also long-term. I'd like to echo several prior questions, really the solutions. So we identified the questions, so how are we going to get the solutions? And the other area I wanted to put into the context is the world has changing so fast for the last 3 decades, as we all know, and going to be faster next 3 decades. So I like to see the panel after the debate, the discussion on this very important area is what's your perspective and position for the committee to continue working on the grand challenges in the context of solutions and also the changes. So all we think there's 14 really the broad enough base, so therefore there will be nothing really significant that will change, considered to be the most important grand challenges for engineering.
So these are challenges for this century. I've heard different people propose different time frames to update them. 50 years, 30 years, decades from now. Is 2100 the right time to update them? Does anyone have a thought on?
Seems to me we're conducting a social experiment right now with a report written in 2008 that what kinds of impacts can it successfully have? And that is, I mean, it's remarkable what's happened in 7 years. And there's this proposal from Callistos to reach out to the developing world's academies. I'm much more interested in seeing us do more with what we have here than to start splitting hairs over the details of that document. It's good enough to create excitement, passion. Kids' books, a good idea. I mean, what does this academy do more than it's doing already? These people in the room know a lot more about that than I do. And what does the academy do? We got this report out, and now what?
Very good. Please go ahead.
I think a lot of importance has been given to this issue in the academy. We heard yesterday about the Scholars Program, the VEST scholarships. I think they're all very positive and already making a good contribution. It's clear that more could be done in schools. I like Farouk's suggestion of a book for kids on each one of these. I would suggest to the Academy that they ask the membership to join in collecting the experts from a given area, those that focus, experts on solar energy, on nuclear power or whatever, and gather together and then work with industry as well. One thing that kids want to know all the time is, even back in school, what am I going to actually do? What's the job? Where's the opportunity? I mean, I can see this grand challenge, secure cyberspace. What am I going to do about that? Where am I going to be able to find a role in these things? And then work with industry somehow, use this as a job. You know, the round at universities, spread the word into schools too. There are great jobs in these areas. If there aren't, you're not going to attract the kids. I mean, Jackie said before, I mean, why do the kids not want to do engineering in Singapore? I bet it's because they don't earn as much money for a start as they would as bankers. I mean, that was the only silver lining to the banking crisis, but they're back at their bad habits again, paying themselves a fortune that's unearned, rather than redistributing the money better. So that's my suggestion to the Academy, that it really works with industry for a start to identify jobs associated with all of these and where they might be, and how people progress to that.
It's interesting because the guys always look at jobs, right? But when I go to the schools, and some of the schools I go to are the girls' school, in junior high schools, you see the girls, the eyes light up when they realize, wow, you mean an engineer made this dramatic impact on humanity for the whole globe. That's when it appeals to them. Right? Because a lot of them, they are very good in science and maths, but then they choose to become medical doctors because they can see the difference they can make to the patients, right? So you appeal to different groups of youngsters differently. And this is the type of things that I can see that really light up, and they go, oh, you mean engineers do that? They really make such a huge difference? And this is something that we want them to feel when they're young, and then we want them, that's when we tell them, come to do research internship with us. And that's when they come again and again.
This is one of the successes of the grad challenges. Every story I've done, they've remarked about women student engineers very interested in this, is that this is something we should maybe think about leveraging out of the grad challenges. Oh dear, I've forgotten this item. I think you go next.
Very good. Thank you. I am Kun Mo Chung. I am former president of Korean Academy of Science Technology. And first of all, I thank you for the hospitality you gave to us. And this morning, we had a very good meeting among foreign members under the leadership of Dr. Ruth David. But I wish to compliment the leadership of Dr. Mott in doing these grand challenges for engineering. Now, since I am from South Korea, which was the poorest nation in 1950s in the world, now Korea is doing somewhat well. We are a member of the Club 2050, and many people are asking me the question, how did you do it? How did we do it in this achievement? Because of our leadership, national leadership, and the leadership of science technology community. Because our first president said, we are going to build our nation through science and technology, period. So at the time, we were not a member of the United Nations, but we were one of the charter members of the IAEA, International Atomic Energy Agency. And then we had another president who really went through this nation building through science and technology. So what I'm saying is, leadership is a key. It's not just the leadership among engineering community alone, but national leadership. And here, the members in this room are really members of that leadership. So we have to really expand our influence beyond engineering community, and we have to be actively seeking the progress of the nation and also welfare of the people. Now, I'm saying this because in 1970s, we carried one project called Science Technology Policy among 10 nations. And the 10 nations is Argentina, Brazil, Colombia, Peru, Venezuela, Mexico, India, Egypt, Macedonia, and Korea. After 40 years, we compared our note. So it's not just talking, but action is very important. Action. So when I joined Dr. Juma's creation, NESC, at Kenya, I said action, not talking, but action, however small, we have to go through. But engineering means action. So I want to appreciate what you helped for developing countries, and I really hope discussion in this room does not confine ourselves in the North American continent, but also all the nations which try to develop themselves. So let's work together, and we want to have action. That action goes through service to the entire mankind. So I thank you very much for this forum. Thank you for your effort. Thank you.
Very, very good. Yeah. We only got about 5 minutes, folks, so it's probably just going to be 1 or 2 questions. Thank you, sir.
This is only a comment. I'm Tom Buttinger from University of California, Berkeley. It's to be in the positive side, to give more hope than Alec might have given us about fusion. There's been a game change in the last year and a half with respect to materials, superconducting materials. And Alec might be well aware of it, but he doesn't want to make a promise that something is going to happen because we've been getting promises for over 60 years. But this game change has to do with a new design for confinement, along with the credible now development of YBCO magnetic tape or superconductor. And so there is a promise. There's promise for modular, small devices that is change in the game plan. So maybe Alec would like to debate that, but I would hope not, because all I'm saying is that there's technical promise. And to read about this, look in a recent issue of Science. And
do you want to disagree, Alec?
Dick told me. I'm very disappointed. I thought I had been encouraging. I mean, I read this article in Science. It's a very, very good article. I read it, every word of it, and I tried to point out that the spherical tokamak with the new superconducting, high temperature, did hold out some new promise. So I thought I'd done that, so if I didn't do that, I'll do it now. But the skeptics are still there, believe you me.
We're at 12:30. I'd like to give this fella a chance, and if they tell me we can take the people who are standing, unless we need to cut it. I do need to tell you that lunch is out in the tents after this event, so don't forget to eat. Sir, go ahead.
Yeah, my name is George Belford. I'm from Rensselaer Polytechnic Institute. I think most of you know it's the oldest engineering school in the English-speaking world. My reason for coming up here is I think many of us here are thinking, what can we do personally? So I have a suggestion, and I also have a suggestion for a grand challenge that's for the whole group, for the National Academy. So my first suggestion is very simple. Ideas come from research, as we heard from the Korean gentleman, and action. And I think we should, so there's been developed a very nice movie instead of a book for kids of the age of about 6 to 8 called the Molecularium. I don't know if anybody's seen it. But I would like to suggest people get together and we try to develop a movie for engineering, not just for molecules, but actually for engineering. What is engineering? What do little kids learn? How do they build? What can they build, etc.? So that's my first suggestion. And I think the society could do that and we could do it. The second is a more serious comment, or I guess they're both serious. The second one is for research, we depend, and many of you don't realize or do realize this, we depend on funding from many sources, and one of them is the National Academy of Science, the National Science Foundation. We are really a stepchild at the National Science Foundation. We are limited in the funding that are given to engineering universities and academics, and I believe we should start to push a real grand challenge, and that is to find and have our government set up a National Engineering Foundation, where we could in fact have a separate and distinct area of funding. Thank you.
Very good.
I have a quick comment. I will be no more than 30 seconds.
Go ahead.
The comment, I totally agree with Dean on his comment on educating the politicians. Unfortunately, we have problems at both ends of the spectrum. One area we don't believe in science. The other area we believe by shutting every coal mine down we can stop global warming. Global warming is a natural phenomenon. As long as we've had the planet, we've had global warming, climate change, coastal erosion, and as a group we should be dealing with the consequences and putting plans in place to deal with the inevitable changes the planet will see. Thank you.
Next.
All right, Dan is going to have a few words. I think he might have a hard question too. Thank you. Do you have your mic?
Yeah. Oh my goodness. Well, I really do like a spirited debate, so I appreciate very much the comments, and I thank Dan. Thank you very much for moderating this panel, and I thank the panelists very much. It's really been terrific. I think we had a wide-ranging conversation on this, and I think it was really important we had the time to look at it. But there were really some themes that cut very strongly through everyone's comments, which are really strong takeaways. For example, there's a very strong focus on youth in this and the importance of youth, and you can't start early enough. And that is clearly a message for us. It's all about connection and excitement of this youth. It's not about the details. To start with, if you get them excited, they'll get the details. It's all about essentially kind of the idea of movies and about bringing themes in for the youth is very important. It was also a strong message about humanity and about multidisciplinarity and about globalization, about the global focus. All the things we try to teach in engineering, by the way, are naturally embedded in these topics, and everybody brought that up continuously, especially if you want to bring in women, if you want to bring in minorities involved in this as well. There was a very strong pitch on education, children's books, and other very good ideas, and actually getting not just education at university level, but really in Common Core education, and that came up as well, and that's something that we can also push. So I think there are a number of strong themes in this. I heard the feeling that the academies do have a role in this, and the academy's principal mission actually is as a convener. You know, the academies actually don't execute and don't do things. It convenes other people that do things. It convenes a panel like this that does things. So we should use our convening power to maximize the impact we can have on these questions we've just been talking about. I thank you all very much for coming. I really do thank the panel very much for its work 7 years ago and its work today as well. And this has been really a very motivating and positive panel as well as meeting for me. Thank you all very much.